If you have been in the AI automation space, you have probably heard of RAG, short for Retrieval Augmented Generation. In simple terms, it's like giving your AI a memory boost. So instead of the LLM relying only on its training data, it first retrieves information from a database or a knowledge base that you provide so that it can generate a smarter and more accurate answer. For example, imagine asking ChatGPT about your company's policies, right? So instead of guessing and coming up with hallucinated answers, it pulls information right from your company policy documents so that it gives the user a context-aware answer. In this video, I'll show you how RAG works inside of n8n and how you can set it up using Supabase. And by the end of this video, you will have your own RAG system running, which would be ready to use, and you can just go ahead and plug it into your client projects. Sounds good? Let's get started. Alright, before we go ahead and learn about RAG, we'll have to know about the concept of vector databases. First of all, you'll have to know how it differs from a regular database, right? For a regular database, we do search using keywords, right? But in the case of a vector database, we use meaning to search a vector database. So what we have here is an example of a vector database. So a vector database is an n-dimensional database. So it can have n dimensions, but for simplicity, here we are using 3 dimensions to show how it works. So all these are data points in the vector database. So here's what a vector database actually does. You can see a lot of different points on this 3-dimensional space, and each of this point represents a piece of information. So it can be a piece of text, it can be a paragraph, or it can be a document in itself. So each of these points would represent information, and the AI, instead of storing all of this information as plain text, it would instead store them as vectors. So for example, all these information across the n-dimensional space would be stored as vectors. Alright, so in this case, maybe cat would be a vector, which would be having the coordinates 0.9, 0.8, 0.2. Dog, since cat and dog are semantically similar in meaning, they would be grouped next to each other. So dog might have a coordinate of 0.85, 0.75 and 0.3. And wolf might have a coordinate of 0.8, 0.7 and 0.4. So all these are semantically similar in meaning, and they are grouped together as you can see here. And a separate vector, maybe if we are to consider apple, since apple differs in meaning from these vectors, it would be grouped, it would have a separate coordinate. For example, apple might be 0.1, 0.2 and 0.9. So the idea is simple. The words, paragraph, text or documents that are semantically similar, having similar meanings, would be grouped together in this n-dimensional space, and those having different meanings from this specific group would be placed in a different area within the n-dimensional space. So this is the whole concept of a vector database. So in this example, we have a search query, and this search query is kitten. So when you type in a query such as kitten, the system doesn't simply search for a keyword kitten. It actually searches for vectors that are close by. For this example, wolf, dog and cat would be similar in meaning to kitten. So it is placed in proximity with these vectors so that it helps AI to find key information based on its meaning and not the keyword itself. So I hope you now have a clear understanding of what a vector database is. This is the fundamental concept behind retrieval augmented generation. So you don't necessarily need a vector database for RAG, but it works best if you use one. So that is the whole concept. So there are like 3 essential processes which happens behind the scenes. So let's take a look at that next. Alright, so let me walk you through what happens behind the scenes in RAG. So for this example, let's say we are designing a RAG system for an e-commerce store. So there will be a chatbot on the website for the store where we can ask questions regarding the order, regarding the store policy, on returns, on replacement, replacement, shipping, or whatever it might be, right? So let's say, for example, we have a store policy document which is almost like 50 pages long. So there it would have a lot of detailed policy statements that a customer might have a query about. For example, there are like 3 statements that I have highlighted here. Customers can request a refund within 30 days of delivery. Free shipping is available for orders above $100. Return shipping costs are covered by the customer. So what happens in the first step for RAG is chunking. So what exactly is chunking? So chunking is basically breaking this entire document or a knowledge base, whatever it might be, into small chunks, and each chunk would hold a paragraph or multiple paragraphs or stuff that are similar in meaning. Chunking is more of a precursor to vectorization. So this would be the first step. So for example, here the first 3 policy statements we have chunked together as a first chunk. There'll be multiple different chunks for the document. So for the next step, each of these chunks would be embedded and vectorized. All right. So what happens is we convert each of these chunks into numerical values. For example, we have a vector here, which is 0.91, 0.82, 0.20, which represents the refund policy. All right. And we have a vector here, which points to the shipping policy. And we have another vector which points to the return policy. So this is done so that each of these can be categorized better and stored in the n-dimensional space. So once this is embedded and vectorized and stored in the n-dimensional space, which is our vector database, what happens next is querying, right? The user would query. For example, if this is a chatbot that is at the front end for this whole RAG system, what happens is user would have a query. For example, the customer might ask your chatbot, can I get a refund after 25 days? So this is a pretty valid question, right? What happens next is a retrieval. So that is the R in RAG, retrieval. So what happens here is this question from the user is also embedded and vectorized, and it is also stored in the vector database. So while storing this, the AI would compare this vectorized query to each of these stored vectors. So for example, we have like 3 vectors already stored in our vector DB, and this vectorized query is compared with each of these stored vectors, and we check which one this would go along with so that all of those are similar in meaning. For in this example, so refund after 25 days is the query, and it would pair along with the refund policy. So it would fetch the statement inside refund policy, which is that customers can request a refund within 30 days of delivery. So we have retrieved the necessary context. So context retrieval is done. We have the input query from the user, which is can I get a refund after 25 days? And using the context retrieved and the original query, the LLM drafts a final response, which is yes, you can request a refund as long as it is within 30 days of delivery. So this final answer gets displayed back to the user, and the entire RAG process is completed. So these are the processes that happen behind the scenes in a RAG system. So the first one would be chunking. So that's a one-time thing. Every time you upload a new knowledge base, it's chunked and stored into a vector DB. While storing it, it does 2 things, embedding and vectorization, and then it gets stored to the vector database. And the next part is querying the vector database, which would eventually retrieve the necessary context for our query. With the retrieved context and the original query, the LLM combines them and generates the final response. So I hope I was able to make it as clear as possible. For the next step, let's go inside n8n and build this workflow and test this out for ourselves. So I'll see you in n8n. Alright, now that we are inside n8n, let's go ahead and set up our RAG pipeline. So before we begin, we need a knowledge base to work with. So for this particular example, we are going to use a store policy document, which serves as a backend for a customer support bot for an e-commerce website. So let me show you the document real quick. This is a comprehensive store policy document. It answers common customer queries based on shipping policy, costs, international shipping duties and taxes. It answers questions about order tracking, incorrect shipping address, returns and refunds, etc. So this document has everything a customer has a query about, and if not, it would direct a human in the loop who would answer the customer query based on escalation levels. This is the entire knowledge base that you'll be using in this example, and as I mentioned, I've uploaded this to my Google Drive. Now let's go back to n8n. So for the first step, we'll have to add a Google Drive node to access this document. Let's do that first. I'm gonna click on plus. Now let's go ahead and search search for Google Drive. So I'm going to type Drive here. I will choose Google Drive, and under Actions you can choose download a file. Select that, and once its properties appear, you'll have to set up a Google credential here. I've explained in detail how to set up a Google credential in a different video. I'll be linking that in the description. All it takes is 5 minutes and you can just set it up easily. Feel free to check it out and come back if you want to. I have already linked my Google credential. As you can see, I'm going to select it, and for the resource I'll set it as file, and for the operation I'll put it as download. And if I click on this, I can search for the document, and as you can see, the store policy document PDF appears here, and all I have to do is select it, and I'll go back to canvas, and you can see that the download node is added and a trigger node is also added before that. So what this means is you can just click on execute workflow and the workflow should execute. So let's try clicking on execute workflow and see if the file is populated. I'm going to click on execute workflow, and as you can see, that workflow is executed successfully. I'll double click to open this node, and the store policy document is successfully displayed as the output for the Google Drive node, and that confirms that we have access to the file. Okay, now that we have access to the knowledge base document, what we'll be doing next is chunking and storing this into a vector database. And for this particular example, we are going to use Supabase for the vector database, and I'll show you how you can add that. I'm gonna click on plus. We will search for Supabase, and you can see Supabase and Supabase vector store. The first one would have all the relational database stuff, but we are going to use a vector store here. So click on that, and underneath the options, you'll have to choose add documents to vector store. So I'll select that, and you can see that the document from our Google Drive appears here on the left side on the input pane for the Supabase node, but we'll have to set up credentials for Supabase. So let's go ahead and do that. All right, so now I am at the Supabase website, and it's supabase.com, and once you are here, you have to set up a project. Let's click on start a project. So you'll be prompted to make an account. I'll go ahead and do that now. So once you create your Supabase account, you'll be prompted to create a new project. I already have a project here. Let's go ahead and create a new project. So click on new project, and once you do that, let's give it a project name. So I'm gonna give it something like n8n test database, and you'll also have to set up a database password. So I'm gonna set up a password here, and once you do that, you can select the region but leave it as it is. Most probably it's optimized to your closest region, so I'm gonna set it as it is, and then I'm gonna come down and create a new project. So you can see that I have created a new project, n8n test database, and if you can see on the top right here under project status, if you just click on that, you can see that the database is live and is healthy. Now what we have to do is we have to go towards bottom left and click on project settings. So once that is opened up, you have to select data API. Click on that, and you essentially need all these details to make a connection to your vector store from inside of n8n. So we are gonna grab a couple of important details from this page. So the first thing that you'll have to copy is the project URL. So I'll copy it from here, and I'll go back to n8n, and once I'm back inside n8n, I'll open the Supabase vector store node. I'll click create a new credential, and inside the hostname field, I would paste this value, the project URL that we copied from Supabase. So I just copied it here, and for this service role secret, what we'll have to do is go back to Supabase, and once you're inside Supabase, you'll have to go to API keys. Click on that, and once you do that, you can see the service role secret on the right hand side. You can click on reveal and get it revealed. Just copy that and paste it back inside n8n. So now I'm back inside n8n. I will paste the service role secret, and once you do that, you go and click on save, and you can see that the connection is tested successfully, and we have established a connection with the Supabase vector store. So for the next step, we'll have to select a table from the list, but we haven't created a table yet. So if you click on this, you can't see any table present here. So what we'll have to do is we'll have to go back to Supabase and create a table. So I can show you a quick and easy way to do that. We can go to the docs here, click on that, and this has all the details regarding how to set up a Supabase vector store and how to create a table. So what you have to do here is just scroll down, and you can see that there's a quick start for setting up your vector database. Click on that, and you'll be directed to this page. And from this page, what you have to do is you have to copy the SQL code. Just copy it from here. So once you've copied the SQL code, you'll have to come back to Supabase, then go to the extreme left, click on SQL editor, and paste the code that you copied inside this editor, And once you do that, you'll have to enable an extension before you go ahead and run it. So what we'll have to do is come over to the left side again, click on database, then we'll have to come down to extensions and search for vector. And once this pops up, make sure you go to the right side and enable it. I have already enabled it. So before you run the SQL code, make sure that you have this enabled. And now let's go back and run the SQL code. I'm going to click on SQL editor, and since the extension vector is already available, you'll have to delete the first 3 lines from the code. And once you remove that, we are all set to go ahead and run this code. So let's run it, and you can see that it's a success and the database table is created successfully. So let's go back to n8n to verify this. All right, now I'm back inside n8n, so I'm gonna search for this. You might not see it immediately. What you'll have to do is go back and press on these 3 dots and click on refresh list. And once the list is refreshed, open this up and you can see the documents table created here. Now let's go ahead and select it, and you'll have to set up one more thing here. Under options, you have to click on add option, and the query name would be auto populated as match_documents. So if you have given a different table name here, you'll have to give the same table name here as well under the query name. So make sure that is correctly mapped. So once that is done, we are all set, and let's go back to the canvas. All right, so now that we have successfully set up our vector database, now as we discussed earlier, we'll have to go through 2 steps. So number 1 would be chunking it, and then we would embed it so that we can vectorize the data. All right, so we'll start with chunking. So in order to do chunking, what you'll have to do is click on plus, and you'll be shown 2 options here. The first one would be the default data loader, and you can also use GitHub document loader. So for now, let's just stick with default data loader. So I'm going to select that. So if you see the properties node for the default data loader, you can see that on the left hand side we have our knowledge base, which is a PDF document, but it is stored as binary data. So you'll have to select the same here. So we are going to switch from JSON to binary. So once you do that, it gives you the option to select how you want to split up the chunks. So there is simple, which is splitting every 1000 characters with 200 character overlap, and you can also go for custom, but let's stick with simple for now. So I'm gonna select simple, and you also get the option to choose to load all the input data, or if you want to just load specific data, you can also do that. Right now I'm gonna load all the input data because we are gonna make use of the entire knowledge base. And once you do that, the chunking part is done. So now let's go back to the canvas and select an embeddings model to do the embedding so that the vectorization process is complete. So let's go back to the canvas. So for the next step, we'll select our embeddings model. I'll click on the plus button under embedding, and here you get a lot of different options, but I'm going to choose the OpenAI's embedding model. So I'll click on that, and you'll have to set up an OpenAI credential inside of n8n. So if you haven't done this already, so I have already made a video explaining this in detail, but I'm going to link that in the description as well. It will only take you 5 minutes to set it up. And once you have the credential set up, you will have to select a model for embedding, and I'm going to stick to text embedding 3 small, and that is all that you have to do in terms of embedding. And let's go back to the canvas to test this out. All right, so now that we have set up everything, we'll quickly run this to see if our knowledge base is being fetched from the Google Drive, and if it's chunked and embedded properly and vectorized and stored inside this vector DB. So let's test this out. I'm gonna execute this workflow and test it out. I'll click on execute workflow, and you can see that the Google Drive is accessed, the file is being chunked and embedded, and you can see that around 18 vectors have been made from the file that we uploaded in our Google Drive. So let's go back to Supabase and see if this vector database is created. So I'm going to go back to Supabase, and once you're inside Supabase, you'll have to come down here and click on table editor, and yes, we can see the documents table created here, and these are all the vectors that each of these document chunks point to, and you can see that around 18 vectors have been created, and these are the vectors that represent each of these data points in the n-dimensional space. So we have successfully created a vector DB with all the data from the knowledge base properly mapped into each of these vectors that we see on the right side. Now for the final part, we are going to create an AI agent that can talk to our vector database, and it can query all of these data using natural language, and we can test it out and see if it's able to fetch these details accurately from the vector database. So let's go back to n8n. Now that we are back inside n8n, let's go ahead and grab an AI agent node. I will click on the plus button here. I'll search for AI agent. I'll add an AI agent node. I'll drag it over here so that we'll have a separate section here for querying the vector DB. So in order to talk to our AI agent here, we'll need a chat trigger. So we'll be talking to the vector DB using natural language. And for that purpose, we'll make use of the chat trigger node. So I'm connecting this to the AI agent. So next we'll have to connect an LLM for our AI agent. Let's click here. For this, I can use maybe OpenAI chat model. So I'm going to select that and I'm going to set it to the basics 4.1 mini for now. And I'll go back to the canvas. So we have connected a chat model, and here is where things get interesting. Right now what happens is that your AI agent has no memory. So if you ask a query about a certain store policy, for example, using the chat interface, and the next time you ask a follow-up question to the original question, the agent has no memory as to what was asked previously, right? So every question is treated as a separate new question and the whole process is repeated again. So we don't want to do that, right? We want our AI agent to be context aware and it should have proper memory of what is happening with each query that is asked regarding the vector store, right? So that is exactly what we are going to do right now. In order to add a memory, I'm going to click on this plus button, and usually for simple use cases you can always add a simple memory, but for a vector database it's always best to go for a Postgres chat memory so that you can directly access the past interactions and store it as well inside of your vector store, which is Supabase in our case. So for this case we are going to add a Postgres chat memory. So click on that. Once you click on that, you have the properties node coming up. You will have to set up a credential for this as well. I'm going to show you real quick how you can do that. You will have to click here and create a new credential, and these are all the fields that you'll have to fill up. So setting this up is a bit different. I'm going to show you how you can do that. Now that we are back inside Supabase, we are going to connect n8n with our PostgreSQL database, which we will be using it as our short-term memory. So basically every question from the user and every response from the AI agent gets stored in a separate Postgres database, which is then used as context every time that user comes and asks the AI agent a question regarding the vector database. What we are going to do is we are going to set up a connection, and in order to do that you come over here and click on connect, and you'll get the option to connect your project. Click on this drop down which says direct connection, and you can choose transaction pooler instead. And once you click on that, you can see that you get the option to view parameters. Click on that. Here we'll get all the necessary details that you can use inside of n8n to connect to your PostgreSQL database. And number one is the host. You can just copy it from here, go back to n8n and paste it inside the host field. So I'm going to paste it here. And the next you need, and for the database you can just set it as Postgres, and for the user you go back and get the user details from here, copy it, go back to n8n and you can just paste it here. And for the password, here we'll have to set up the database password that we initially used earlier in the video, where we created a database password when we were setting up our project in Supabase. So make sure that you enter that password here. So I'm going to paste that password here, and once you do that, click on save, and you can see that the connection here is tested successfully and we are ready to go. And once you do that, you'll also have to make sure that you set the correct port number here. For now it would be 5432, but if you check here you can get the right port number, which is 6543. I'm going to copy that and I'll paste it here instead of 5432. And once you do that, you go here and click on save, and you can see that the connection is tested successfully and we are ready to go. So for the final step, we'll have to vectorize our input query. So when I explained the concept of vector databases in the beginning, I told you that we'll also be vectorizing the input query. So in this case, the user would be chatting to our AI agent using natural language, and that query would also have to be vectorized, right? So in order to do that, we'll have to set up a vectorization tool here, which would be Supabase again. So we are essentially going to do the same thing that we did here. So let's go ahead and add a Supabase tool here. I'm going to click on plus. We are going to search for Supabase and add a Supabase vector store. We already have our Supabase account connected, so I'm going to leave it as it is. And here under operation mode, we'll leave it as retrieve documents as tool for AI agent. And here in the description, I'll mention something like call this tool if you want to search for store policy. So I'm gonna give it a simple instruction. The table name, again, we'll have to select our table name, which is documents. We have done that previously. And for the limit, let's set it as 4 itself. And is there anything else? No, I guess. So let's go back to the canvas, and now we'll have to embed. And so for now, we'll have to embed the input query. So either we can add a new embeddings model here, or you can just drag it and use the same embeddings model that we used previously. So I'm gonna make that connection to our earlier embeddings model. So this part is now sorted. We have the workflow complete. Now we are going to test this out and see if we are able to query the vector database using our AI agent. Let's test if we are getting an accurate response based on our knowledge base supplied. So let's do that next. All right, now we are all set to test this workflow out, and let's start by executing this. I'm gonna execute this so that the knowledge base is fetched from the Google Drive. It is chunked, embedded, and vectorized, and we have around 18 items as we saw earlier. And now that we have the whole knowledge base vectorized, I'm gonna open up this chat model, and I'm gonna ask it a query regarding my shipping policy. So I'm gonna ask it something like, what happens if the product is damaged on arrival? So let me try this. You can see that the workflow is in action. It is referring the data store, and it has come up with a response. If your order arrives damaged, you should take photos of the damaged item and the shipping box, then contact the company at support@auraliving.com within 48 hours of delivery to arrange a replacement, right? So let's check if this is correct. So I'm gonna cross-reference this with the original knowledge base. So let me try that. Okay, so this is the knowledge base and the exact section where we have the answer to our query. And we can see that if your order arrives damaged, please take photos of both the item and the shipping box, and we have the email address and the delivery window appearing, and you can see that there is an accurate response to the incoming customer query, and that means our system is working as expected. Let's see if we can ask it something challenging. All right, let's ask it about stolen packages. So I'm gonna ask it a query. For example, let's ask it, my package didn't arrive, it was stolen, what to do? And now let's see if it answers it correctly. So the workflow is in action. It is referencing the knowledge base, and we have a response. Aura Living is not responsible for packages that are stolen from a property after being marked as delivered by the carrier. And we can just cross check it to be sure. And yes, it is saying that the company is not responsible for packages that are stolen after being marked as delivered by the carrier. So you can see how powerful a RAG system is compared to a traditional database. It is very intelligent. Since we are using AI in this picture, it can naturally understand the question and the intent from the customer's query, and it can vectorize that query, store it inside our existing knowledge base, try to find where it fits within the n-dimensional space. It will fetch all of the policies that are related to the incoming query. Then it uses the retrieved context and the input query, and it gives you the perfect response, right? And this is just the very beginning. There are a lot of use cases that you can automate using this powerful concept. For example, you can add multiple knowledge bases, multiple sources in the backend, or maybe it's a voice agent which answers your customer's calls. It can reference these documents simultaneously when it's talking over the phone to your customer. It can understand what they're trying to ask. It can store context regarding the conversation so that the next time the customer calls, it knows what the previous issue was with the product and what this customer is currently facing, so that it can give a more natural and useful response, right? So remember that I mentioned earlier that it stores all the context regarding the conversations using the PostgreSQL database. So let's check that out, and I can show you how powerful it is. Once you go back to Superbase, after this conversation, you can see that we also have one more database created here, which is named n8n chat histories. And this is the power of RAG, right? It has automatically understood the conversation, and it has stored the conversation within a new vector database. You can see the message here. The human is asking asking what happens if the product is damaged on arrival, and the AI responded this, and the human asked something else and the AI responded this, so that the next time the same user comes up, we can store these unique identifiers for this conversation and tag it to that particular user, so that the answers are more to the point and useful for that particular user, right? And so that is how powerful a RAG system is. So it's Retrieval Augmented Generation. I hope I was able to make it as clear as possible for you, and this is just the foundational system. You can build a lot of systems using RAG. It's super powerful, and I urge you to try this out and see if you are able to replicate the same system. And once you have this set, you can maybe start building more and more advanced systems on top of this. So I hope this was useful. If you found it useful, please leave a like and consider subscribing. I will be making more in-depth tutorials on RAG. If you'd like that, please keep subscribed so I can keep making more videos that can help you out in your AI automation journey. So that's it for this video. I'll see all of you on the next video. Take care and keep automating.